Hey guys, today we are going to talk about early brain development in infants. The main idea that you should take from this is that the information in babies' brains develop as they acquire new skills. This information evolves at a very rapid rate during the first years of life. So some scientists argue that infants' brains is like a blank slate ready to be written on by their experiences. Do you think this view of the brain is correct? Like, do you think that a baby's brain is just blank? It's like a blank canvas. It's there for, caregivers to give them morals. It's there for, them to be able to social development correctly, emotional, intellectual? Or do you think that, maybe some babies are born with information already programmed into their brain? Think about that, because it's something that I would like to talk about. Research shows that the environment has a major impact on brain development. By providing new activities to stimulate all of their senses, it helps develop new abilities. A baby's increased brain function is due to the quantity and quality of experiences the baby has. So the more experiences they have and the quality of those experiences help increase their brain function. Again, this also goes back to failure to thrive. If you don't give the baby those experiences, if they're just laying there watching TV all day, they're not getting good quality experiences, and they're getting no quantity of experiences at all. They're just laying there, they're having no interaction, their brain is not being stimulated by anything, so they don't have increased brain function. Development happens faster in the first year than at any other time of life. At birth, the brain has billions of neurons, which is a neuron is just a nerve cell. In response to experiences, babies' brains immediately begin to begin to develop links between these neurons. The link between neurons is called a neural pathway. So think of a baby's brain as a roadway. The nerve cells are the different roads, and then they develop these links called neural pathways from one stop to another. These pathways wire the brain so that it can control different body functions and thinking processes. Neural pathways are created quickly. For examples, babies just 4 days old have demonstrated that they are able to distinguish between whose voice is who. The brain is divided into different sections. Each section controls a specific function or job of the body. One of the most important parts of the brain is the cortex. The cortex is part of the brain's cerebrum, and its growth permits more complex learning. At 1 year, a baby's cortex is far more developed than it was at birth because they've had more experiences. Their brain has constantly been processing what's going on around them. As babies experience more input from the world around them, their brains respond by forming more connections in the brain. The quality of caregiving affects brain growth. As caregivers hold, play with, and talk to an infant, the baby actually uses the experiences to build the brain's capacity. So if you're giving your baby all these quality experiences and you're always talking to them or singing to them and reading to them, your social, emotional, and intellectual development just far exceeds another child who doesn't have these things. And so these are the children that excel in school because they have caregivers at home that care about them and that they know that they can trust, and that they have bonded with, versus an infant that didn't bond at all, and they don't have that caregiver to fall back on if something is wrong. Okay, so we're going to talk about the different parts of the brain. The brainstem controls involuntary activities such as breathing, heart rate, and your blood pressure. Your cerebrum receives information from the senses and directs the motor activity. It controls what functions like your speech, your memory, and your problem solving. Most of these activities occur in the outer layer called the cortex, or some people call this the cerebral cortex.
Mama, did you get my charm book?
Okay. The cerebellum controls your muscular coordination, your balance, and your posture, and you can see that it's located in the back of your skull, or the back of your brain, if you will. Your pituitary gland releases hormones that control growth, metabolism, and your sexual development. Your spinal cord controls your simple reflexes that do not involve the brain, and also coordinates activities on two sides of the body. Okay, so your thalamus controls the way emotions are expressed and relays sensory information from other parts of the brain to your cerebral cortex. The brain contains billions of nerve cells called neurons. Neurons are tiny messenger cells that transmit information in the brain and nervous system through an electrical chemical process. Your neurons are connected by axons and dendrites. An axon is the connection between the neurons that transmit instructions from cell body to another neuron. Each axon is coated with myelin, which is just a fatty insulating substance, and that helps to speed up the information that's transmitting from one nerve cell to another. A dendrite is a branch-like feature at the end of each axon that receives the electrical messages from other neurons. And this process actually begins when the baby is developing in the uterus, and then after birth, this process happens more quickly whenever they're actually able to see your experiences, go through them. They have things that are stimulating their brain, because in the uterus, whenever they're in the womb, they really don't have anything that stimulates their brain unless they hear like a loud noise or somebody's talking to them or something of that nature. Okay, so neurons are nerve cells. Oh, I am so sorry. Hold on. It's not going to let me go back. Oh my gosh. So sorry about that. Okay, so neurons are nerve cells in the brain that control your body's functions. This is a whole neuron. This is what it looks like. The step one of how neurons work are your dendrites receive information from other neurons. You can see your dendrites are located right here, and passes it on to the body of the nerve cell. They reach towards other dendrites of different neurons for transmission. Okay, so that dendrite passes that information to the body of the nerve cell, called the cell body, where information is processed. So it goes from the branch of the tree to like the actual trunk of the tree. The nerve cell sends messages through the axons, which transmit the messages to the dendrites. So you have your dendrites, which are your nerve cells. That's not what I meant to say. I'm sorry. Your dendrites, which are like your little branches, and then you have your cell body, and then you have like your little axons that are transmitting information to different dendrites. Again, you have your myelin, which is just coating on an axon that makes it the transmission easier and faster. Step 4, chemicals called neurotransmitters are released by the axon and cross the gap to the dendrite of another nerve cell, and that gap is called a synapse. More dendrites indicate increased learning. The more dendrites that neurons grow, and the more links that develop between neurons, the more neural pathways that are created in the brain. So the more experiences that a baby has, the more pathways that they have, the faster their brain is processing things and remembering things. The more pathways give the brain more power, and it can do more tasks and control more actions. The increased number of connection gives the brain more flexibility. This increase in connection is the direct result of sensory input. Systems of neurons work together to influence how babies see and hear, as well as how they think and remember things. This process is how all learning takes place. The system is so flexible that humans continue to learn new behaviors and form new ideas all of their lives. The connections between neurons are not permanent, so if something has not been repeated to you, then you could forget it over time, but you're constantly learning new things, and you can always learn new things, but you can also forget those things and how to do some of those things. Building of new connections is called branching. The new connections become part of the brain as new skills are learned or new experiences are stored. And that is all. If you guys have questions about anything, you let me know, and I look forward to